Hello everyone. So welcome to our next video in sklearn.preprocessing package. So today we are going to talk about categorical features or how to handle them, basically how to encode them. So let us see. So the agenda for this video is as follows. We'll see the prerequisites, introduction, we'll see types of categorical data, types of encoding, we'll see some documentation, official one, and then we'll look at the sample code. So the prerequisites are Python, NumPy, and Pandas, just like almost every other video which will be there in this module. And introduction. So firstly, what is categorical data? So it is the type of data that can be stored into groups or categories, with the help of some name or a label. So basically, something that is not numeric can be called as categorical. But even if it is possible that even if you can see numeric values, it is still, it can still be considered as a category. That's a different part. But categorical data basically means, like, for example, let's say if you have a column gender, so the categories will be male and female. So that is the kind of data which is called categorical. For example, another example would be if you have a vehicle, so they can ask you if it is a two-wheeler or four-wheeler. So as of now, these two would be the options. So again, that's a categorical data. Now, munging of categorical data is really important part of pre-processing. That is because the machine learning library in Scikit-Learn does not handle categorical data well. So we have to encode these features into numerical values so that the model can be trained well with these. So it is really important, and that's why we have to handle these. So now let's see the type of categorical data, the types. One is nominal, the other one is ordinal. So nominal means unordered categories. So where they are not ordered, where kind of you cannot decide which one has more weightage or something like that. So again, an example would be male or female. And for nominal kind of categorical data, you will have to use maybe something like a one hot encoder. But for ordinal, which is ordered categories, now you can understand bad, neutral, and good. Just looking at the example, you know that bad is something of the worst kind. Neutral is maybe okayish, and good is obviously a positive, a positive thing. So bad, neutral, and good, so you can put them into levels and you can clearly understand the weightage. So you can mark good as 3, neutral as 2, bad as 1, or something like that. But you can it's ordered, so that's what ordinal is. And for this kind of categorical variable, you can encode it using ordinal encoder or label encoder. Both are more or less the same. And now let's move on. So the types of encoding. So there are various types of encoding, and not all are mentioned here over here, but then most of the common ones are mentioned. So there is one hot encoding or dummy encoding, as you call it. We'll be seeing this in the sample code. But what basically one hot encoding does is it takes a feature and it will create multiple columns, multiple additional columns in that data set. So for example, if a feature has three possible values, three possible categorical values, then three new columns will be created, binary columns. So the column, for example, let's say the first row has something like some category, and now three new columns will be created. And if that category is, let's say, something like good, for example, if you want to use one hot encoding over there, then under the good column there will be one, and under all the the rest of the two columns there will be zero. So looking at the binary value in the specific column, you understand that what was the original value, and this way you're also encoding it into a numeric value. But like I said, for ordinal, we'll try not to use one hot encoding. It is better to use ordinal or label encoding. But this was just an example, and it also depends upon the data set as to what encoding you should use. So label or ordinal encoding, they both are similar, and you can almost call them as same. They have minute differences, but what they basically are is that they will give labels to the categories. So for example, if you have let's say category of earphones like wired, then you have headphones, you have wireless. Let's say these are the three categories. So you can just label them starting from 1. If it is wired, just label them 1. If it is wireless, label them 2. If it is headsets, label them 3, something like that. So it just labels every new category as a new number. And if the same category value is there, then the original assigned number to that will be used. Now target encoding. So what target encoding is, it derives some kind of value from the target variable, and then it uses that value to replace the original categorical value. Now that might be a bit difficult to understand just by the word, and we don't have target encoding inside the sklearn.preprocessing package. We do have it in Scikit-Learn library, but not inside the preprocessing package. So however, I will just show you on a whiteboard. So for example, if we have this kind of data set, you have animal, then you have target, and then over here a new column is added which is encoded animal. So this usually replaces the original column, but just for the sake of presentation, I'm showing it to you as a different column. Now, how did we get this value? How did we get 0.4 for cat? How did we get 0.5 for hamster and 0.67 for a dog? So that is using the target. Now, if you count the number of the number of rows that have cat as their animal, so you get 3, 4 and 5. So there's a total of 5 rows that have cat. Now you just have to add the targets over here, or just something like a probability of 1. So if you see that 3 of the rows in which the animal is cat, they have 0 as the target, 1, 2 and 3, and the other two have 1. So basically the probability of 1 over here would be 2 upon 5, since there's total of 5 cats. So that is 0.4. Now we are just replacing cat with 0.4. And similarly again for hamster. So for hamster, if you see, there's just 2 hamsters and one is 0, one is 1. So again the probability of 1 is be 1 by 2, that is 0.5. So it's as simple as that. Now you can also use the mean. Over here we have used the probability. Now the mean here would be the same because it's just zeros and ones. But what if the target has bigger values, maybe something like 5, 10, or even numeric values? So at that point you can also use the mean. So in this case I'll just show you an example. So if we have total of 5 cats that you saw, now we'll just add the target 1 plus 0. So that is 1 plus 0 would be again 1. Then we have 0 again, 0 again, and this one is I missed. So a total of 2 ones, the rest are zeros, so the addition is 2. Now you are dividing 2 by 5. The total times cat is appearing in the data set. So that again comes to 0.4. So now it might seem the same because it's already being replaced by 0.4, but it is different because we used probability of 1 to replace, since it's a binary feature. But when we have numeric values, you can also use the mean, and that way you can encode it. So this was an example of target encoding. And even let's say if you want to do our next encoding which was mentioned is frequency encoding. So if you want to do frequency encoding, you're basically just replacing it frequency. So the frequency of cat occurring over here is 5. So your cat will be replaced by 5. Wherever there is cat, you'll just have 5. Similarly, hamster, it's just occurring twice, so hamster would be 2. And dog is occurring thrice, so you'll have 3 for dog. So it's as simple as that. This is frequency encoding. So yes, and for label encoding, let's say you can just give cat as the number 1, Hamster would be 2, cat was already assigned 1, so again 1 here, dog would be 3. Now hamster would be 2 again because we've already assigned it, cat was 1, dog is 3, cat was 1, and dog is 3. So this is label encoding or ordinal encoding over here. And yes, so let's go back to the presentation. So we talked about target encoding and frequency or count encoding. I just showed you what frequency or count encoding is. Now remaining types of encoding are binary encoding. The name itself suggests that the categorical features will be just encoded into a binary value, that is either 0 or 1. Now how can you encode a categorical value into binary value? So what you have to do is you have to first encode it into some kind of numeric value, and then you have to distribute it into two bins. Now how can that be done? Now for example, if you use any other normal encoding technique, you will get certain kind of value, and now for that value, let's say example, if you're getting values from 1 to 10, so now if you want to encode it into binary, then you can say something like, if the value is below 5, encode it as 0, else encode it as 1. So that way it's just encoded into zeros and 1. So that is an example of binary encoding. It is more commonly used for numerical values, but for categorical values it can be done this way: first encoding into numeric and then binary encoding on it. Now feature hashing is using a hash function and then encoding that feature. So you can see about that in detail. Now let us see the documentation. So this is the official documentation from the Scikit-Learn website. And pre-processing data, we have already talked about in the previous video. We talked about missing values, so imputation. Now we are seeing encoding of categorical features, which is over here. And if you see that in this they talk about ordinal encoder, which I've already talked about, and there is also one hot encoding. So like you can see, one hot encoder. Now they are trying out different examples or how you can tweak a model or how you can tweak the encoding, and they're just trying different ways, and you can look at them as and when required. So these are the only two types of encoding talked over here. So those are the two which we'll see in our code. And yes, then this is the next topic. So like you see, it's just one hot encoding and the ordinal encoding. So let us go back. I think next we have coding. Yes, so let us go ahead and see the sample code. So we'll continue in the file which we used the last time, and I'll just write handling categorical values so that we can start. So firstly we'll have to import numpy and pandas, just like every time. Numpy as np and import pandas as pd. So now we will take a new variable x equals to pd dot data frame, and we can use so I had typed it out, so I'm just pasting it over here. So we are taking np.array, and I've taken first column for gender, second for blood group, and third one for something like education level. So and then I'm reshaping it to 5,3, that means 5 rows and 3 columns. So I'll just I'll also take it into a new variable so that later on we can modify and we still have the old data set, and I'll just print it for you. Okay, so I forgot to write the column names. So x dot columns equals to gender, blood type, and we have, let's say, edu underscore level. So this is our data set. You can also use any of the existing data set from the Scikit-Learn library, but since this is just a small data set, it is easier to understand what kind of changes were made. If there is any change, you can instantly recognize that, oh yes, this is different now. Whereas in a large data set, it is difficult to understand which column was changed, and you have to, really focus to really know the difference. So we'll be using this, but in real use cases, you will directly use it on the data set that you have. So you'll have to, of course, uh, store it as a data frame in pandas, and then you can do it. So now we will first see ordinal encoder or label encoder. So for ordinal encoder, this column is suitable, the last one, that is education level, because there is an ordered set of values like low, medium, and then high. So now from sklearn.preprocessing, I'll import ordinal encoder. Now encoder equals to ordinal encoder, and x dot, so this is the name of our column, is equals to encoder dot. So we'll just fit it into the encoding, fit transform, and again x dot edu underscore level dot reshape. So we have to reshape it, and else it will be an array if you don't reshape it. So now we'll just print x. Okay, so we're getting an error. Okay, so I forgot to use values. We are reshaping the values. Yes. So like you can see, the education level has been changed, and medium is now 2. High has been taken as 0, and low has been taken as 1. So it has assigned the numbers to them. So that is, this is working kind of like a label encoder. Now this is giving us a float value, so you can just change it to dtype equals to int, and that should do it. Yes, so that works. Now we just also see label encoder. It is more or less the same, but we'll see it. So I'll just copy this part, import label encoder. Now let's say le equals to label encoder, and we had earlier stored x also in the variable called df, so we can use df over here, so it doesn't really affect our original data set. And df edu level equals to le dot, again we have to do fit transform, and again df. So now we'll just print df. Yes, so this has also encoded it into the same manner, and now we will see one hot encoding. So again, from sklearn.preprocessing, import one hot encoder. Now let's say one hot equals to one hot encoder. Again, we'll take the data type as int. So let us take a new variable, like let's say n. So n equals to pd dot data frame, and we take one hot dot fit transform, and we have to take. So now in our data set, if you see, both gender and blood type, so both of them should be encoded now. So we'll encode both of them using one hot encoding. So if you just understand that gender has only two possible values, so because of gender, two new columns will be added, and because of blood type, so in this blood type has 1, 2, 3, 4, and 5 possible values. So 5 new columns will be added because of the blood type. 1, 2, 3, sorry, 4. There's O minus, O plus, AB, and B plus. So there's just 4, and 4 new columns will be added. So now we have to take gender and blood underscore type. Now we have to change it to array, and we'll name the columns as F, then M, then we have AB, we have B plus, we have O plus, and we have O minus. Now we have defined the columns. Okay, so there's one extra bracket over here. So n, and again now, so we are taking n as a new data frame. So we have added these two columns. We have encoded and added, but the edu level is still left. So now we are going to add that column to this data set, or to this data frame, equals to x dot edu underscore level. Now we'll just print n. So there you go. So you can see that gender has been replaced by two columns, F and M. So in the first one, our gender was M, that's why F is 0 and M is 1. Again in the second row, it's the same. In the third, fourth, and fifth row, the gender was F, so that's why F has 1 and M has 0. Similarly with the blood groups. Now if you see the blood type, you can just relate and understand that O minus, that's why O minus is 1, the rest is 0. So similarly for all the other rows. And like I said earlier, it will be changed into 4 different binary columns, and that's what has happened. And our education level was encoded as label encoding, with using label encoding or ordinal encoding, and that's why the education level has this. So now you have you've converted all the categorical values to numerical values. Now you can go ahead and use any kind of algorithm you want to, and then you will have proper result. So that is it from the coding part. So that's it from this video. Thank you for watching, and I'll see you in the next video.